Hey guys, this is Mrs. Harbin, and this is Algebra 1. We are looking at Chapter 4, which is all about inequalities. And today we are going to continue to solve inequalities. We started it a little bit last class. Let's go ahead and continue. Our lesson objective for today is that you, the student, will solve inequalities using both the addition and multiplication properties of inequality, which we learned in our previous lesson. When solving inequalities, we've already said the process of solving them is very similar to the process of solving equations. We want to isolate the variable by eliminating any extra terms, and whatever we do to one side, we have to do to the other. We then want to use inverse operations to undo what's been done to the variable. We want to get that variable all by itself. So the process is very similar, but we do need to remember that there is one difference. When multiplying or dividing both sides of an inequality by a negative number, we need to remember to reverse or switch or flip that inequality symbol, only when multiplying or dividing both sides by a negative number. So let's take a look at some more examples. Again, we started this last class. We are just continuing what we've already done. Let's solve 3x plus 5 is greater than 20. Well, this is our x term. This is what we want to get by itself. So we need to eliminate this plus 5 that's on the same side with it. And we eliminate a positive 5 by subtracting 5. We're going to subtract 5 here, and whatever we do to one side, we have to do to the other. That leaves us with 3x is greater than 15. We then need to undo this times 3. It's being multiplied by 3. We need to undo that by dividing both sides by 3. And when we do that, we get x is greater than 5. We do not need to flip the sign because we did not divide by a negative number, so the sign stays the same. If we want to check our answer, we can take any values of x greater than 5, so 6, 7, 8, 9, 10, plug this back into the original equation and make sure that they are true statements. So let's say we plug in a 10 here. Let's check our work. 10 is greater than 5. 3 times 10 plus 5 is greater than 20. 3 times 10 is 30, plus 5 is greater than 20. Pardon my handwriting here. And 30 plus 5 is 35. That's greater than 20. That is a true statement. 35 is greater than 20, so that means our x is greater than 5 must be true as well. Let's take a look at a second example. Negative x over 3 plus 8 is greater than or equal to 12. Negative x over 3 is our x term, so we want to eliminate this plus 8. We eliminate a positive 8 by subtracting 8. If I subtract 8 from the left, I also need to subtract 8 from the right. And when I do so, I get negative x over 3 is greater than or equal to 4. Sorry, that should be minus 8. There we go. Now, x is being divided by a negative 3. In order to undo divided by, we need to multiply. We're going to multiply both sides by negative 3. Now, when we multiply both sides by a negative number, we do need to flip the sign. So this greater than or equal to flips and becomes less than or equal to. Our negative 3 divided by negative 3 cancel out, and our negative 3 times 4 is negative 12. Okay, so I had to pause, take care of the dog, and now I am back. As we were saying here, let's take a look at 4x minus 3 times 2 plus 2x is greater than 10. Now, just like before, we need to get rid of these parentheses, and we're going to do that with some distributive property. We're going to combine the like terms to get the x term by itself, and then solve for x. So when we distribute here, we're going to distribute that negative 3. Negative 3 times 2 is negative 6, and negative 3 times 2x is negative 6x. We're then going to combine our like terms. So we have a 4x and a negative 6x that we're going to combine. That gives us negative 2x minus 6. We want to get this x term all by itself, which means we need to eliminate this negative 6, and we do that with a positive 6. So a positive 6 on both sides gives us negative 2x is greater than 16. X is being multiplied by negative 2, so we need to reverse that. We need to undo that by dividing by negative 2. Because we're dividing both sides by a negative, we do need to switch our sign. So you can see the sign was flipped here. And we end up with x is less than negative 8. Again, to make sure that that's done correctly, we can choose any values that are less than negative 8 plug them back into our original equation, and it should give us a true statement. Try this one on your own. Pause the video and then come back once you've worked it out to see if you were able to solve this example correctly. All right, you hopefully started by distributing that 5 and then combining like terms on the right-hand side, which gave you x plus 4 is greater than or equal to 3x plus 30. We then need to get all of our x terms on one side and all of our non-x terms on the other side. So I am going to subtract x from this side. I want my x terms only on the right-hand side here. Oh, I'm sorry, that's not what the example is doing. The example is going to put our x terms on the left and our numbers on the right. So we're going to subtract 4 from this side. Whenever we do to one side, we have to do to the other. That gives us x is greater than 3x plus 26. We're then going to get rid of the x term on the right-hand side. So we're going to subtract 3x from the right. Whatever we do to the right, we also do to the left. That gives us negative 2x is greater than or equal to 26. In order to get that x by itself, it's being multiplied by negative 2, so I now need to divide by negative 2. And because I'm dividing both sides by a negative, I am going to flip that sign. Remember, we only flip the sign when we are multiplying or dividing both sides by a negative. I get x is less than or equal to negative 13. To make sure this is done correctly, I can pick a value that's less than or equal to negative 13, plug that back into our original inequality there, and I should get a true statement. Now let's try some word problems using inequalities. Jeffrey wants to fence in a rectangular garden, and he has up to 60 feet of fencing available. If the width must be 5 feet more than half the length, what are the possible dimensions of the garden? So let's translate all of these words, which is quite wordy, into some math expressions here. We know the length, we're going to assign the variable L, and we know that the width is 5 feet more than half the length. So we can translate that into this expression. 1/2 the length, which is L over 2, plus 5. That's what our width is. So length is here, length, and width is 1/2 L, or L, plus 5. I'm going to write that with a capital L so that it doesn't get confused with the 1 here. And we know that when we're talking about fencing in, we're looking at perimeter. In perimeter, we add up all the sides. So L plus 1/2 L plus 5 plus 1/2 L plus 5. And we know that it can't be any more than 60. It can go up to 60, it can be equal to 60, or less than 60, but it can't be more than 60. So let's go ahead and write that inequality. 2 times the length and 2 times the width is going to give us our perimeter. We know our perimeter has to be less than or equal to 60. So let's plug in our numbers here, our expressions. 2 times the length plus 2 times the width, which is just 1/2 L plus 5 that we plug in there, has to be less than or equal to 60. And from here, we're just going to solve for a variable L using our steps that we learned when we were solving equations. And when we solve for L, we're going to end up with L is less than or equal to 16 2/3. So our length must be less than 16 2/3. We're going to convert 2/3 of a foot to inches, 12 inches in a foot. So it must be the length must be, less than or equal to 16 feet, 8 inches. All right, today we solved inequalities, which we started last class, and we continued this class using both the addition and multiplication properties of inequalities. And we reminded ourselves in practice that when we are dividing or multiplying inequalities by a negative number, both sides by a negative number, we do have to flip this sign. If you guys have any questions, be sure to ask me next class.